ये है लिस्ट सामने, मैं लिख के दे दूं आपको नीचे। लिस्ट के साथ ही लिस्ट होता है, एक लिस्ट आ गया। ये अभी कौन कौन सा आ रहा है? ये है ना लिस्ट सामने, आप तो इस लिस्ट को देख लो। नहीं देखना नहीं है, वो बोलना पड़ता है ना, वहाँ पर मैं अलग चलूंगी ना। वो ये है, अरे ना ये तो ये तो अब ये कह रहे हैं कि मैं इनको आप कॉल करूँ ना, कॉल करूँ, ये क्या आ रहे हैं और मेरा सब्स्टिट्यूट भी आ रहा है, एक और ये कौन है? ये लोग तो आ रहे हैं आज, और ये भी आ रहे हैं, और नहीं एक को किसी को फोन नहीं लगा, सुषमन का तो है ये नहीं पता मुझे, बराबर बोले फोन अब ये उठा नहीं है। हाँ कोई बात नहीं, बुला लेते हैं। नहीं मेरा तो नहीं है, मेरा Hello. So the in a slot number 1 we have 5 presentation, right? And I'm calling Aketi Naresh for the presentation. Are you present? Aketi Naresh. The next is Ranveer Roopray. Hello. Okay. The third one is Sumanta, Dr. Sumanta Bhattacharya. So can we wait for 2 more minutes just to call them? So I am calling them to come. Okay. Will you please wait for a minute? Right. Call karo.
Respected Madam, myself Dr. D.B. Jani from GC Dahod. So I don't know when my turn is there because a little bit less number of participants are emailed to me. So can I present now? I am ready with my presentation if some time is available in between.
Yes, sir. Yes, sir. You can present your topic.
How much time is available, Madam, to me for presentation?
We have 10 minutes for the presentation and 1 minute, 5 minutes for...
Hello, Madam. What will be the availability of time to me?
We have 10 minutes.
Please confirm my screen is available, Madam, and my voice is audible.
Yes, sir.
Okay, thank you, Madam. So myself, Dr. D.B. Jani from Department of Mechanical Engineering, Government Engineering College, Dahod, and my post is Associate Professor in the Department of Mechanical Engineering. Today I am going to present the topic, application of renewable solar energy in the desiccant assisted hybrid cooling system. I have completed my PhD in 2017 from IIT and working at different STEM Institute of the Gujarat, published a lot more publications in the reputed journals and also working as renowned reviewers, also working as editorial board members, published some books, participated in overseas conference and working as a editorial board members in the continent and abroad, as well as a well-known speaker, having so many citations credited to my work and of having the lifelong learning. Today we have come to our topic, desiccant cooling. So prior to selecting any topic for the research, scholars are interested to know the future of the same. So here I have shown the timeline for the publications of the area of desiccant cooling. So as you see that as decade may go, exponentially rise in the number of publications in the reputed journals. So what about the desiccant cooling? First of all, we may go through the definition of air conditioning. Air conditioning is the simultaneous control of temperature and humidity. Along with that, you might have to provide fresh air by proper ventilation, some air circulation, and cleanliness of the air. There are many parameters that may affect the air conditioning, namely meteorological, physiological, psychological, clothing, etc. So the term thermal comfort is not easily quantifiable. Day by day, as you see in the table, different applications will rise the required flow of ventilation layer according to the ASHRAE standard. So whatever may be the manufacturers of HVAC machineries may go through and to follow these standards, and that standard will become tight day by day as far as the spoiling of outdoor ambient due to global warming. Earliest method of cooling the air is evaporative cooling, in which we evaporate the water by passing through some mechanism called primary and secondary air carrying the water particles, and that evaporated into air. So other end we may got the cold air. So one of the limitations of evaporative cooling is that it might work only in the area where relative humidity is very low. When relative humidity of the ambient condition is high, evaporative cooling degraded it performance. So at that time we may go for another conventional cooling technique known as vapor compression system, in which compressor is the source for compressing and condensing to use the refrigerant in the cycle, and the same coal is used for the criteria of producing conditioned air for cooling as well as dehumidification. So for some limitations of the traditional vapor compression based system is that it cools the air below dew point temperature. So your compressor has to work more, and it resulted sometimes into the overcooling when temperature at the exit of evaporator is less than the design supply temperature. So you may have to provide excess heat for reheating the same to meet the supply conditions, and that decreases COP of the system and having a limitation with regarding to sustainable energy use. So the conventional cooling system on psychrometric chart shown as a blue line. There are different methods used for controlling the humidity, is by the heating or is by the cooling. So by the condensation you can remove the moisture present in the air to make it dry by decreasing the surface coil temperature of the partition surface, maintaining below the dew point temperature of the surrounding air, so that the moisture content in the air can easily get condensed and separate out. So if it will be maintained below the freezing point temperature of water, then instead of having droplet condensation of moisture from air, ice formation will took place. So far in big hotels, some big auditorium where large number of occupancy and large number of outlets are there, instead of using the direct cooling, we may have to go for the chilled water system. We may cool the water around 5 to 7 degree in a huge chiller tank, and then that chilled water easily can supply at the different outlets with help of pump and mechanism. So whatever may be the temperature range in case of direct cooling and chilled water system, you may have to got it through the graph provided. So this kind of system is called a separate humidity and temperature control system. So books are available for the further study of the same. So there are different systems that makes use of the renewable solar energy for cooling and air conditioning, namely absorption, adsorption, desiccant cooling and ejector cooling system. So out of comparison, as seen in the table, we may got desiccant cooling with have the optimized regeneration temperature as well as the COP for the different applications, having its relative merits and limitations. So why we go for changing our conventional air conditioning system? Because cost of handling the humidity in conventional system is high, because of compressor has to work more, as far as the sometimes a problem of overcooling makes reheating of air, and this will increases the cost of cooling. As far as the provision of ventilation air for the maintenance of indoor air quality also degraded the quality of incoming air. So these are the limitations of the presently used conventional cooling systems. So for comfort health condition, we should have to maintain temperature around 78 to 80 degrees centigrade and relative humidity around 50%. So why we have to maintain humidity around 50%? From the graph, you may see that different impactance growth will be minimum to this range. This same can be also clear with this simple chart also. So for the dehumidification, we may have the different technique: chilled water, chilled brine, direct expansion system, and sensible heat system. So this vapor compression based cooling system already been taught in undergraduate level, so cannot got much into the detail. So day by day, as you seen from the graph, number of HVAC equipment sold decade by decade will go on ameliorating. That will increases the load on power grid. So far, as most of the 70% of the power in the power grid to be developed by the fossil fuel, most of coal based, so that increases pollution in environment, resulted to the succeeding global warming, and ultimately that may also increases the duty of air conditioning and outdoor atmosphere become harsh. So in desiccant cooling, instead of producing cooling and dehumidification as seen from the graph in a single cooling coil, we may have splitting this operation individually into dehumidifier and cooling coil. So dehumidifier, by having the matrix laden desiccant wheel to be removed by the partial pressure difference between dry desiccant material and wet moist air supplied in a process air side. So after exiting from dehumidifier, air becomes dry, is cooled further in a cooling coil. So cooling coil may be vapor compression type or a conventional cooling. You can get benefit here by downsizing the cooling coil, because it has to handle only sensible load. Latent load will be taken care of by dehumidifier. But irreversibly, here to make the wheel working in cycle, we may have to provide the regenerative hot air that make the reactivation of the dehumidifier by disrupting the moisture interrupt the desiccant surface. So we may have to provide the regeneration air oppositely in the reactivation area section of the dehumidifier. And here we are using conventionally electric kettle, but there are diversified sources for reactivation may be used, such as waste industrial heat, solar energy, or low grade thermal energy, such as like natural gas, etc. options. So desiccant cooling may give you environment friendliness as a little bit lesser requirement for the refrigerant. As far as some case, you may have to opt it with the evaporative cooler also. So around most 25% of the conventional cooling can be downsized. So sources of thermal energy to be provided for reactivation may be diverse, like solar, waste heat, or natural gas. Indoor air quality maintained to be as per standard defined by SRA by providing high ventilation rate because of capability of desiccant to remove the airborne pollutants. They cannot circulate it again and again as happening in the conventional split air system. The total system working at atmospheric pressure, so maintenance problem as well as the making of material of construction will be simpler and cheaper. So desiccant system can be used for diversified season as per different configuration of supplying reactivation and adsorption energy by summer or monsoon or winter conditions. So this may be the different salient features we discussed earlier about the desiccant materials. So desiccant based cooling system at a time is the combination of clean energy, clean technology, as well as make a clean environmental condition. There are different types of desiccant cooling system based on its type of desiccant material, whether solid, liquid, or hybrid kind. So there may be the different application as well as geographic point of view. The cooling system can be used in the different part of the world. Mostly silica, activated carbon, synthetic polymer, etc. used as solid desiccant material, and liquid desiccant material used are triethylene glycol, lithium chloride solution, and calcium carbonate. Sodium desiccant cooling can be termed as adsorption only water collected to the surface, while liquid desiccant are used as absorption as material will take part throughout the structure or chemically through the structure of the material. So the capability of a material to work or opt as desiccant are its low surface vapor pressure under its dye condition and should have high capability to absorb the moisture around 10,000% of its dye weight and should have the low heat capacity. This is the principle of the desiccant cooling. Moisture laden wet processor supplied air is flow through the dehumidifier where it gets dry by dissolving the moisture by the process of adsorption, and then dry air further cool in evaporative cooler and supplied to the conditioned room. And oftwise we may go for regenerating the dehumidifier by passing hot air through regenerator. So this is the liquid desiccant dehumidifier, but mostly it has a certain limitations like corrosion carryover or crystallization, and it creates the problem of confusing the fumes, and so for mostly used for the air conditioning purpose but used for the industrial temperature control purpose. So this is all about in short my topic, desiccant based cooling systems. So any question to my presentation, all the listeners are invited so that I can answer his or her question. My voice is audible?
Yes,
you may
sir.
write any question you have with the presentation.
Yes, sir. Sir, I want to know one question.
Yes, madam.
Sir, abhi presently, if the MTech scholars or a PhD scholar want to do some research in this particular area, what are the avenues where they can do the research, sir?
Yes, just a minute. I will have to share some of the slide of mine, madam. It will
Right,
take
sir.
1 minute. Please confirm my slide is available, madam.
Sir, it is just coming.
Yes.
Now
Yes.
it is
Visible. So
sir.
these are the
Yes, sir.
different scope and objective where the research scholar may put their effort in further for the experimental investigation of this kind of system, numerical modeling of dehumidifier, transient
Right.
simulation of the system for the diversified ambient condition, artificial neural network for predicting the performance in absence of limited experimentation, and thermodynamic analysis. So this type of system experimental setup can be prepared by me at IIT Roorkee. You might
Yes.
see have certain humidifier, cooling coil, as far as the heat wheel for energy conservation. So both top and front view will be available. Rest different temperature, flow, pressure, and humidity measuring devices are fitting in making the setup. So this will be the type of room I have selected for the typical dimensions, carrying the cooling load calculations for particularly 2 to 4 persons, and design the supply conditions. So you may have certain analysis. You may go for different summary of previous work. How can you model the dehumidifier by use of transient simulation system? Suppose you design your system for the condition of India and you wanted the same system for the conditions of Europe. So you might have to use the weather data file in case of that simulation. So that will give you the different benefit with regarding measuring the system performance for selecting any particular location or a part of Earth. So there are a lot more research still required with regarding to the kind of desiccant which consume minimum energy or may get reactivated at a ambient temperature, so that minimum energy gets supply for reactivation, and the system resulted to have a higher COP of the hybrid cooling system.
Right, sir. Sir, one more thing is that,
Yes, madam.
sir, what kind of project means you have shown the project? So
Yes, sir.
if someone is interested for installing the project in their institution,
Yes, madam.
so how we will select the thrust area plus the
Yes,
equipment, hardware
You,
required to
yes.
implement the, yeah.
There are different projects to be invited from Renewable Energy Department as well as the Department of Science and Technology. So you may have to put some core research objective based on some literature survey, or by finding some of the gap in the previous study, so that you might have invited for presentation, make a proposal for the requirement of equipment, as far as some software you require, then that grant will be available for research.
Right, sir.
State government also provides some student startup and innovation policy, SOIC, Department of Science and Technology, for enhancing the research. But for that proposal, as far as its planning should be required.
Sir, if we are implementing a project, it takes
Yes,
lot
madam.
of time for implementation.
Yes,
And
it may take
meanwhile,
4 to 5 months, madam. For 2-3
okay,
months, you might have to go for literature review, finding the gap, then searching the almost tentative cost of the equipments you required for your experimental setup, and then you might have to apply. Scrutiny will require 2-3 months, and after presentation and selection, they will release grant after 2-3 months. So it will require almost about 8 to 9 months duration to complete the task for securing the grant from the government agencies.
right, sir. And meanwhile, we have to go for the that patent filing or publication also for
Yes.
this particular
So
work.
for mostly this kind of detailed project expected from the research scholar, especially in PhD. For MTech, you might go for some simulation work only
Right,
by
sir.
use of software, so that it requires a time duration of 6 to 8 months to complete that dissertation project.
Right, sir. Sir, you are in a reputed institute, IIT Roorkee,
Yes,
and
madam.
I want to ask how the research scholar can get help from the eminent
Yes, sir.
personality like you.
Definitely, our lab is available. Still, someone wants further research should write to our director, and based on the kind of proposal or kind of research one wanted to carry out in the thrust area, he or she might get permitted.
Right. So you are in the mechanical department. I think,
Mechanical
sir.
department.
I think,
I
sir.
have completed my project, madam, from IIT Roorkee during my PhD. Nowadays, I am at Dahod, at MP border,
Great,
at
sir.
Government Engineering College. We also in our institute develop similar kind of system at almost 10th part cost of the overall system I have shown here. So it is not possible that you require lakhs of money to develop some system, but it will require some thousand of rupees. But for that, you might have to go for optimized selection.
Right, sir. Sir, when we apply for a project for any government agency,
Yes, madam.
so in this agency, any new person like that person completed just MTech
PhD,
degree or-
PhD completion will be required for the investigator, principal investigator. The requirement that is he or she should completed his PhD, then he might be eligible to apply for the grant.
Right. Sir, one last question from
Yes,
my
madam.
side.
Yes, madam.
You have done a lot of work in the technical area,
Yes,
but
madam.
if suppose we want the prototype of that, and then after that we want patent, and then scaling up to the business level.
Yes,
So
yes.
what are the process for that, sir?
For patent writing, you might have to contact agent based on the design, which will not be previously published in any form. And then patent office itself will do the innovation, and then that may grant the patent. And some pharmaceutical industry where this type of system will go for them to save the lot more money as far as area is more, and dehumidification rate will be at very low required by them. So
Right.
it will be beneficial in their circumstances.
Means we have to search out the application of that particular
Yes, yes, yes.
work, and then we have to search the area where this type of research can be useful.
Yes,
And
madam.
then we can
Once
file
your
the
patent is granted, the different owner, factory person, proprietor will contact directly with the given communication. Okay, so that they will decide about the exposure of your patent with regarding to industrial applications. Then you might have to find the term and conditions for selling your patent for the duration and kind of application.
Right, sir. Sir, in case of multidisciplinary projects, like
Yes,
you have done the project in mechanical,
Mechanical. Yes, ma'am.
can we interrelate the mechanical project with the electrical or electronics?
Definitely. Certain controls are required in the system. So some electrical student get coupled to this type of project, they will definitely gets motivated to do certain new research in the same area.
Right, sir. And sir, meanwhile, I want to say if a person is doing well in the project area, what
Yes,
they have set up in the lab, they can go for some sort of a workshop or a training program for the students
Yes, madam.
for inside the organization or outside the organization.
Yes, madam.
So, right.
That is the collaboration things. Suppose you are
Yeah,
working in some field India, and similar kinds of researcher in some other countries like Europe, Australia, Germany, then with collaboration among the institutes and MOU, memorandum of understanding, you
Right.
might have to definitely get exchange of idea. Somewhere you might be able to use practical and experimental facilities available. Interconnecting institutes is possible, madam.
Yes, means we can get the collaboration with the international organization
Yes,
as well
definitely.
So they help, sir, for the
Definitely they will have.
like if the
As
students
I go for transit simulation of the system, renewable system, some of the scholars from Malaysia, Australia, definitely in between will contact me, and through online meeting, as it is not feasible for every time to go there and to guide them, but through online meeting, we definitely solve some of the queries that may arise during part of simulation work.
Good. Means the candidate who are working in a private institution,
Definitely,
they can
madam.
go for the project work.
Yes,
And
madam.
they can
In
do
Science
the
Direct, author information is definitely available to the home page of the journal. So if you want to connect, you can say researcher, professor from outside India, you definitely send a gentle email with regarding to his time and availability, so that you might have to go through this type of online meeting for solving the query, any doubt, any errors you find in your model definitely get solved by help of some eminent personalities of that field.
Right. So, sir, can you share your first slide so that we can note down the information, sir?
Okay.
Your
I will have
details,
to
sir.
share.
Yeah, please, sir.
I'm also got registered to the program, so where
Yes,
my
sir.
mobile and other information is definitely available. I'm
Yeah.
sharing my first slide, madam.
Right, sir. Okay.
Interested participant requested to take the print screen and can contact me later.
Yes.
My mobile number and other details are available to my institute homepage.
Right, sir. So, if anyone is having any, if anyone want to know more about the research or what sir have done, you can interact or you can ask the questions.
Research scholars are invited to present any query, any doubt, any guidance.
So it is really a matter of pleasure for all of us that sir is with us and they are sharing their research work what they have done during
Thank you,
the
madam.
PhD.
I always presented this kind of programs, and I am very thankful to you, madam, for arranging a platform for the different researchers, because researchers never become a teacher, is always a learner. After completing PhD, if a researcher stops to learn new things, then his research got vanished.
Yes.
So
So it is
definitely
really
we should
great
try
thing
with
for us,
new
sir.
things.
And we are also planning to do some work in our institute also. And we are, yes, sir. So wherever we will require any help, sir, we will ask
Most
for
welcome,
that.
madam. You are most
And other researchers also, please, you are welcome. You can ask the question from sir, because it's really a commendable thing that sir is giving their precious time with us. They are sharing time with us. So anyone having any query, you please unmute and ask the question to the sir. Or you can put the question on the chat box. So I think, sir, there is no question.
Okay, no problem. Research
And,
scholar may, if they
yeah.
want, contact me later also through my email or contact information available on the institute site.
Sir, I am very, very thankful to you. You have shared your research work, the technology what you have used in the IIT Roorkee, and you have demonstrated us with few slides that you have done the hardware part also. And since we are also looking for such type of things in our institute, so I am thankful again and again. And we have got the greater insight that after doing the project, how can we go for the patent, or how can we get the collaboration from the MOUs, by MOUs and all that. Sir, thank you so much.
Thank you, madam, providing to me my sharing the research.
All right, thank you so much, sir.
Thank you.
So next participants, name Mr. Naresh. Are you present? Mr. Naresh? So, candidate, if you want to share your views, wherever you are studying, where you are working in a institute or in an organization, if you want to share something with the other participant, so you may please share your views. Okay. Else I will tell you something about my research work, what I have done during my PhD. Okay, right. So I'm just waiting for Naresh. Next candidate. Next candidate. Nobody is coming. Yeah. So, dear participants, so I am waiting for the next presenter till I will share my work with you, right? So as we know that today is the era of innovation, right? So we have to do the innovations by applying the novel mechanism for implementing any kind of project or any kind of thought or any kind of strategies what we have in our mind. So in my research, so I have done the research in the area of design and development of advanced metering infrastructure, which is based on the demand side management scheme. So prior to this demand side management work, I served in the area of generation rescheduling, which is a demand of the era. As you know that we are having different government organizations like CEA, like CERC or other organizations, they are working to maintain the frequency constant, right? So they have given us the guidelines how to maintain the constant frequency of the system, as the frequency stability may cause out of synchronization. So my work is basically focused on the implementation of regulatory approach based deviation settlement mechanism for frequency control. So as we know that we are having the sustained power deficiency, right? So power deficiency presently we don't have because we have the renewable options. We are having other options also. We can compensate the demand deficiency with these sources, renewable energy sources. But still, when we are talking about the integration of the renewable in the main grid, so we can integrate it, but there are some issues. There are some frequency issue. There are some voltage issue. So instead of focusing on the work of integration of renewable with the main grid, what I have just checked that whenever the demand increased, what happens in the grid, right? So for doing this, I have focused my work on the deviation settlement mechanism for the frequency control, right? So that causes we have the options like the developed countries, US or UK, they maintain the frequency very, very small range, that is 49.95 to 50.01 only. But in India, we are having the large frequency deviations, right? So in order to avoid these frequency disturbances, we are using deviation settlement mechanism. So we have, in my research work, I have provided the very innovative solutions for maintaining the frequency. And after this generator rescheduling work, I have focused myself on the work of demand side management, where I'm using the renewable energy. So renewable energy is my second part, but first part is to investigate the generation rescheduling methodologies, right? So in my work, what I have used, that is availability based tariff. If power is available to us, then we will provide the power to the customer with a less rate. If power is not available, we will provide it with a high rate. Okay. So I'm using one more mechanism where this is a commercial mechanism which is based on availability based tariff, and this is a commercial mechanism, and it is a paradigm shift for operating strategies to operate the generator rescheduling from conventional method to the new deviation control mechanism, right? So in the MATLAB, I have done the simulation and I have checked it with the real-time utility system. So when I have applied our method with the latest CRC norm 2017 norms and 2019 norms during my PhD work, I have compared my result with the utility results, and I am fortunate to get good results which I have published in the Taylor and Francis publications. This is a good publication work, and I am requesting for the MTech students and the PhD scholars also try to get the publication of your work in a reputed journal, so that you will get the benefit of that in your complete academic career, right? So this is the work, and you can see my name as the main author. that is Manju Gupta, and my guide, Dr. Shushma Gupta, she was present during this program also. So you can write down my name and madam name, and you can get the complete paper on the Google also, right? So one thing which I want to say, that whenever we increase the load, the frequency reduces, right? And when there is too much of demand, when we are increasing the load, a condition reached where we are not able to supply power to the customers. So on that time, we have to shed the load, okay? And the demand side management is a new concept where what we do, instead of shedding the load, we maintain the load by the demand side or the customer side, right? So in this particular mechanism, when we do the demand side management, we are having two options, either to increase the energy efficiency or to use some methods which is called as demand response, which we can do from the customer's end. And during the energy efficiency scenario, as we are using the 5-star rating equipments and all, so we can use the 5-star equipment, we can increase the efficiency of the device, what we are using at the customer end. We can go for the another option that is a very innovative option, that is called demand response. So in case of demand response, what we do, we flatten the load curve through reducing the load in a systematic way. Okay. So in my work, I have focused on the using solar system. Okay. So I am using solar system, and I am comparing the power which is available through the solar system, and I am comparing it with the demand. So at a particular instant, if demand is more than the supply, or we can say if demand is more and the utility power is not available, then what we will do, we will reduce the load. So how we will reduce the load, it is depends on the consumer choice. So consumers actually set their priority. So there are three types of load: critical load, non-critical load, emergency load. So we will automatically switch off the switches the non-emergency load, and we can focus on the critical load and the emergency load. So that load will be supplied through the solar system, or in an emergency, only the critical load will be supplied to the utility, right? So in a coming time, what happens? So what is happening, what we are doing, we are controlling the load at the demand side. We are setting the consumer priorities, and the emergency load is always be shared by the utility, and the critical load is always shared by the utility, and emergency load will be shared by the solar system, right? So there is a concept how we will switch on or switch off the load, right? So that algorithm I have developed in my PhD work. So I have seen that when we give the opportunity to the customers to switch on or switch off the load, or to set their priority, so without doing any intervention with the main grid, what we are doing, we are systematically switching off and switching on of the load, and we are saving the power meanwhile, or we are assisting the utility to utilize the power what is available on that particular time, particularly at the time of peak load, right? So this is the mechanism which I have developed, and I am trying to get the patent on this particular work. Hardware also I have implemented in the Manet. Okay, so in the Manet I have got the opportunity to set the hardware of that, and I have got the results also. So this is a thing which I have shared from my side, and meanwhile, if I have some time, the next day I will share the complete PPT with you, and I'll show my work with you. And we have some other PhD members also in the department itself. So we will try to show the work what they have done in their PhD work. They will share that work with you. So I am requesting if anyone is interested to share their work, they can come on the platform. This is a common platform. This is not a PPT presentation or, yeah. This is not only a, we are not doing the conference and all where you are presenting your PPT only. This is the platform where we are interacting each other. Okay. So if anybody want to share their views, they are welcome. They can come forward and they can share their views. What kind of problem they are facing, okay, or what kind of work they are doing, whether they are in an academic organization or in a research organization, or if they are working in some industry, they can share their views. They can come forward, and this is basically the open platform where we can exchange our ideas and where we can enhance our knowledge. So I am requesting all the participants may kindly come forward and share their views. Anybody interested for the sharing?
Very good morning, ma'am. I share some slides with you all. So, shall I start? Here I am from Oriental College, Bhopal. I would say something regarding my research work, and I would think regarding the overview of dye-sensitized solar cell. For know the depth of dye-sensitized solar cell, that there are the 3 generations of solar cell. So their first generation is regarding your crystalline silicon solar cell. Second generation is regarding thin film solar cell, and the third generation is regarding your latest is. So as far as fabrication technique is concerned, scissor-charging method is applied solar cell to fabricate these cells.
Ma'am, excuse me,
In
ma'am,
second and
please.
third generation of solar cells.
Excuse me, ma'am. Please kindly check your data connection. Your voice is lagging.
Okay. Am I audible?
Yes, ma'am.
Am I audible?
Yes, ma'am.
Now, is it visible to all?
Yes, ma'am.
Okay. So I am starting my work with my introduction. I am Dr. Geetam Richarya Shukla, Associate Professor in Electrical Department in Oriental College, Bhopal. Actually, I would like to share something regarding the latest and novel topic. This is dye-sensitized solar cell, and it is the third generation of solar cell. So before starting the depth of dye-sensitized solar cell, we should know the 3 generation of solar cells. So basically there are 3 types of generation. First generation goes to crystalline silicon solar cell. Second generation goes for thin film solar cell, and the last and latest is goes to dye-sensitized solar cell. So we have selected there 3 parameters to distinguish the 3. First is fabrication technique employed. So as far as first generation is concerned, scissor-charging method is employed to fabricate the first generation of solar cell. As far as second and third generation is concerned, roll-to-roll screen printing technology is used to fabricate such cells. As far as economics concerned, so cost is a very important, very vital role to fabricate the cell. So we see that the cost of first generation is quite high as compared to the other. If we see second and third generation of solar cell, the cost is near about the same, and it is very less costly as compared to the first generation of solar cell. As far as efficiency is concerned, it is the basic performance parameter of the cell. We have seen that 25% in case of monocrystalline solar cell, which is much better as compared to thin film and dense sensor solar cell. If we see the third generation, it's about 15.6% using your liquid electrolyte. So dye-sensitized solar cell is an emerging trend, and now I want to share some fabrication parameters of dye-sensitized solar cell. A dye-sensitized solar cell basically consists, I would like to share a diagram. Here, a dye-sensitized solar cell basically consists of two electrodes, anode and cathode. This is the basic cell. Our anode part has a coating of titanium dioxide. It is a semiconductor, and onto which a dye is sensitized. Therefore, its name is dye-sensitized solar cell. On the other side, a counter electrode has a coating of platinum or any catalyst material, and the fill between anode and cathode, it is filled with the help of electrolyte. So these are the broad parameters, broad fabrication parameters, which we should know before to fabricate a dye-sensitized solar cell. Transparence conductive oxide. Actually, the glass used for dye-sensitized solar cell is not a simple glass. It has a conductive coating. So on the basis of conductive oxide, here two types of transparent conductive oxide are classified. First is indium doped and the second is fluorine doped tin oxide. Here I would like to share a table which distinguishes the ITO, which is indium doped tin oxide, and FTO is fluorine doped tin oxide. So as far as transmittance is concerned, it is seen that the transmittance of ITO is quite higher as compared to FTO. But as we saw, the sheet resistance of FTO is quite low as compared to ITO, which is a very good factor for FTO. As far as we concerned with the temperature during the sintering method, we see that the sheet resistance increases with increasing temperature. So this is the very drawback point of ITO. If we raise the temperature, its resistance also enhances. But in case of FTO, it remains same. It is also a very good factor for FTO. As far as cell efficiency is concerned, we have seen that the efficiency of FTO is much higher as compared to ITO. So nowadays, in the present work in a novel dye-sensor solar cell, FTO is used as transparent conductive oxide rather than ITO due to its high efficiency, due to its constant behavior of sheet resistance according to the temperature. Next and very important part of dye-sensitized solar cell is the semiconductor. Semiconductor layer is used for anode, for making the anode of the dye-sensitized solar cell. So here near about 4 to 5 semiconductors which are normally used in case of dye-sensitized solar cell. First is titanium dioxide. Second is zinc oxide, tin oxide, magnesium oxide, aluminum oxide, and so on. So I would like to share a table which shows a broad difference in the performance parameters of semiconductor material. Here we have chosen two types of semiconductor material because the efficiency of these two are much higher as compared to the other. So while we see the efficiency of titanium dioxide, it is near about 1.01 for a cell efficiency. So according to zinc oxide, it is very high as compared to other materials. So nowadays, titanium dioxide is mostly used in the fabrication process of anode of dye-sensitized solar cell. Now, this slide shows sensitizers. Sensitizers are the heart, are the main part, are the key role of your dye-sensitized solar cell. And basically, there are three types of sensitizers. First is metal complex sensitizer. The next is metal free organic. And the last is very pure and natural dyes or sensitizers. If we see the first metal complex sensitizers, the efficiency of metal complex sensitizer is much higher. It is near about 15.6 as compared to the other. But there are also some severe drawbacks. What are the limitations? The first limitation is high cost. Its cost is very high and it is not very much environmentally friendly. It is hazardous to the environment. Therefore, we look near about the metal-free organic sensitizers and natural sensitizers. I would like to share a table with you in which various synthetic dyes are shown. If we see the performance of the synthetic dyes, we have seen that these all are the ruthenium complexes in which the efficiency of N719, this is the ruthenium complex, is near about 11.18, which is quite higher as compared to the others. These are some metal-free dyes. Actually, these are the synthetic organic dyes, and these are environment-friendly dyes, and they are less costly as compared to the synthetic. So there are a lot of synthetic organic dyes like aniline, bromophenol, methyl orange, crystal violet, carbon fuchsia, and eosin white. So these are very commonly used synthetic organic dyes, and if we see regarding the research point of view, the eosin Y has a great performance as compared to the others. Now I would like to share some natural dyes. These are the dyes. They are come in a natural form. We can use fruits, flowers, leaves. All these extracts are used to make natural dyes. So there are a lot of flowers, bougainvillea, cordia, vixen, hibiscus sabzarifa. And it is seen that as far as performance parameter is concerned, the performance of hibiscus sabzarifa is much higher as compared to the others. Now come to the counter electrode part. The performance of the dye-sensitized solar cell is also depends upon the which type of material you used for counter electrode. So the work of the counter electrode is like a cathode of a cell, and it has a coating of catalyst material. So basically there are two types of coating normally used. First is platinum, second is graphite or carbon. The platinum is very costly, is much higher as compared to the carbon, but its overall efficiency, its overall performance is very high as compared to your carbon. As far as graphite is concerned, so it is good option for the laboratory work for MTech guys, for PhD guys who are not funded with your project. So graphite is normally used. It's a good option. We can use as a material, as a counter electrode material for dye-sensitized solar cell. Now this table shows the performance parameters using different counter electrodes. Basically, we have chosen only two for simplicity. There is a platinum, whose efficiency is much higher as compared to carbon, but the platinum, the drawback of the platinum is it's very costly. That's why carbon is a main option, is a main choice for the researcher to make counter electrode for dye-sensitized solar cell. Now electrolyte, it is the main part, it is also the main part of dye-sensitized solar cell, which is used to regenerate the dye. And electrolyte contains a redox couple also. And electrolyte is a charge transport medium. And basically there are three types of electrolytes available: liquid electrolyte, quasi electrolyte, and solid electrolyte. As far as performance parameter is concerned, liquid electrolyte is the main choice for the researchers. However, it is corrosive in nature. So this is all about my presentation, and these are my some references which I have used. I have near about 7 SCI journals regarding this work with 1 patent, and this all work I did with the help of my guide Dr. Anil Kumar sir, DTU Delhi. So if you have any query, if you have to know, if you want to know any new research, new work, so kindly share with us. This is all about my part. Anyone else would like to? Anyone else would like to say something regarding your new work, your new findings regarding solar cell, regarding wind, or regarding any renewable? So you can share your views. This is a platform to share our views regarding new trends in renewable, in solar, in wind, in any form of energy. So our next session will be started at 3 o'clock. So we can left this meeting and we will rejoin up to 3 o'clock. Thank you everyone to join us.
So am I audible to you? Hello?
Yes, ma'am, you are audible.
Hello, good afternoon. Is this whether there is Manju Gupta, madam? Manju Gupta, madam. Hello.
Yes, sir, she is there.
Sir.
You can share.
Yes,
Yes.
ma'am. I am Dr. G. Muralikrishnan. I would like to present one survey paper related to wind energy. So
Okay.
shall I present in the presentation session
Sir,
from 3 to 4:30?
yes, sir. Yes, sir. Please, 3 to 4:30, you can
Okay.
present.
Okay, ma'am. Thank you. Thank you so much, ma'am. I'll
Now,
mute myself.
yes, yes, yes. Thank you, sir.
Thank you, ma'am.
Good afternoon, all. Our guest for today's session is joining in a while. We are shortly going to start the program.
करूँगा
क्रतुंड महा विद्यारंभे वाले नायकम गुरु सरस्वती सर्वकारी वंदे घासी भवानी मनसा इष्ट देवता कौन है उसका जन्म लीजिए इष्ट देवता कुल देवता
A very good afternoon, sir.
Yeah, very good afternoon.
देवी पूजनम भगवती
Very good afternoon to all of you. I would like to start this session. The immense research area of Dr. Anil Kumar sir cannot be explained in few words only. Before inviting Dr. Anil Kumar sir as a keynote speaker, I would like to share a brief introduction of respective speakers. He has more than 16 years of experience in energy technology. Currently, Dr. Anil Kumar sir is an associate professor in mechanical department and also additional coordinator of Center of Energy and Environment in New Delhi. He has also served as assistant professor at Energy Center, Manipur. He has completed his PhD in solar energy from Energy Center, IIT Delhi, India. Also, he was postdoctoral researcher at Energy Technology Research Center, Department of Mechanical Energy, Prince of Sofia, University, Thailand. His area of specializations are energy technology, renewable energy, solar energy applications, energy economics, heat transfer, nature rubber sheet drawing, and environmental issues. He has completed many research-funded projects in these areas. He has published more than 200 papers in international peer-reviewed journals and more than 100 papers in international and national proceedings. Also, one granted patent and 3 published patents in his credit. He has supervised so many PhD scholars and master students. Now, I would like to invite Dr. Anil Kumar sir to share their valuable findings in his keynote session. Over to you, sir.
Yeah, thank you, Dr. Geetam and Dr. Gupta and other HOD and other participants. Thank you very much for calling me over here in this meet, national level research scholar meet, innovations and recently advancement in renewable and sustainable technology. I hope most of the participants are from scholars only, either MTech scholar or PhD scholar, right? So, okay. So actually, the coordinators have assigned me the responsibility for this innovation and technological advancement in solar thermal systems. Solar thermal system or renewable energy systems? I forgot actually. So anyway, okay, renewable energy. So
Renewable energy system.
okay. So yeah, let me share my screen. So my talk basically that is concentrated on the solar thermal applications basically. Okay, and just I would like to explain how the solar thermal energy can be implemented for industrial applications. So as we know, all we and others means we are developing country, and definitely we have certain plan for our development or come under the category of the developed country, right? So so in that case, and for the prosperity of any country is totally depends on energy consumptions, per capita energy consumption or energy consumption. Yes. Okay. So so I mean to say, because as we know, because this conventional energy sources, everybody knows the problem with the conventional energy sources. We have highly dependent on fossil fuel. Okay, so fossil fuel, one major problem is our economic aspects, because a lot of our foreign exchanges goes in the purchasing of this crude oil and other things, and even coals also, because Indian coal is not such a good quality. A lot of ash contents are there, so we purchase this coal is from Indonesia and Australia, right? So in that sense, and for the development, and to enhance the living status of any citizen of any country, definitely a lot of energy consumption is required over there. And at the same time, like we are developing country, we China and other, and as we know, so in our country or the developing country, we are a lot of development towards the industrialization, right? So if industrialization is there, we want to develop, we want to enhance our GDP, definitely the energy is needed. Okay, so so that is one cause, the economic aspect, and another way is the this environment. Okay, so in environment point of view, the definitely as we know, the situation of the carbon emission. Okay, so we have ultimately we have to switch over towards the renewable energy systems, right? So definitely I would like to congratulate these coordinators for organizing such an event, and such kind of the event I'm sure would be very useful to the young researchers, MTech scholars or PhD scholars. Or definitely they will have some idea, so what could be the latest field and what they can do. And although a lot of literature is available now free of cost in the Google itself, okay, and elsewhere in the other startup, definitely we have to pay something. But in the, as far as concerned with the institute, most of the institute, they are providing this facility, the research publication and all. Okay, so let me start with this. My topic of presentation is innovation and technological advancement in solar thermal system. So I will give you some brief idea about thermal systems. So what are the how the solar energy, solar radiation, in fact solar the short wave radiations, how they can be converted into the useful thermal energy, right? So generally people think like solar energy may not be much useful in case of the industrial application when it has a very high temperature. Okay, that means high temperature is more than 600 or 700 or 800, but it is not that much of true. But okay, it's fine if suppose you leave the power generation. Okay, a direct application you can do. Direct application means the process heat applications. Okay, so for few country, if suppose some industrial or industrialized country, on an average 30% of our energy consumption goes to the industrial consumption itself. 35%, almost 30 to 30 globally. It varies from 32 to 35%, right? So now out of that, almost 74% of any industrial consumption is the share from the process heat applications. Process heat application, it may be the hot air or it may be the steam. Okay, so this is very indirect heating. In many industries, the indirect heating is required. For example, the textile industry, pulp and paper, food and beverage. Okay, and many times this chemical industry also, refinery also. Okay, so but if we analyze the operations, if we have analyzed the different operations in the industrial, these industries, textile, food and beverage, okay, pulp and paper, chemical industry, and food process industry, right? So in these industries, you will not find any application more than the 220 or 250 degrees centigrade. So such temperature, the application of such temperature like up to the 200 to 250 degrees centigrade, we can easily achieve with the help of the solar thermal. And of course, these are all the quality, but I can understand some drawbacks are also there, like this solar energy is intermittent nature. Okay, so to make it more reliable, solar thermal systems, we need to have very good solar this thermal energy storage system also. Okay, the perfectly designed solar thermal energy storage system. So there could be many ways to store the solar available excess amount of the solar energy or excess amount of heat energy we can store in the form of the sensible heat energy storage, latent heat, or other thermochemical chemicals are there. Okay, and that energy we can use some other in the later time, means the off sunshine or the cloudy weather, or say to make it more system feasible, economic feasible, or reliable, we can hybridize it. Okay, so along with the one renewable energy source, the another energy resource we can apply it or implement, right? So thank you, Geetam, for giving this wonderful introduction. And now, so my talk is very simple. Basically, I knew most of them are from the student only. So some fundamentals and some the scope. I would like to discuss about the scope of research, further research in the solar thermal systems, solar thermal area. Okay, as especially I just want to correct it with the industrial applications. Okay, so in that the content is the introduction, type of the solar thermal system, different energy, solar energy to thermal energy conversion systems. I will give you some brief idea, and the application of solar thermal system, and what are the opportunity, how the researcher can involve themselves in the various research area of the solar thermal applications. Okay, and I would like to give my some of my research lab work. My student have done some work, so that is have a very good publication. Okay, so so this, as we know, the highly efficient means of among the renewable. Okay, so solar thermal system, for example, this flat plate, right? It has an efficiency of around up to the 60%. Okay, so because we are getting the freely available energy, and we are the system is converting the to the 60%. Okay, so that is fine. That's the system. The disturbance is from my side.
No, sir. This was technical fault from. Please continue.
Okay, so and of course, this is clean and green source of energy, because this statement is partially correct. Okay, so if suppose some system is fabricated, okay, during fabrications definitely some energy is involved over there, and during fabrication, of course, conventional energy is being used for raw material to final product. Okay, suppose, for example, the flat plate collector is there, the casing in flat plate collector casing is there, and absorber plate is absorber tube, if suppose it is the water heating collector. Okay, so these are the metal basically, and metal insulation, and some casing could be made from this PVC or insulated material. Some is insulated material. Okay, earlier it was made by also from the aluminum sheets also, but now people are avoiding because of the to make it more lightly and thermal insulated system. Okay, so now during for the fabrication of the system, definitely some carbon. Okay, and roughly we generally say the 1 kilowatt 1 kilowatt of electricity produced from the coal-based power plant produce 0.98 kg of the carbon. Okay, so this is the thumb rule. So so now definitely the system. So this statement, now clean and green source of energy. So this is partially correct statement. Okay, some environmental degradation is there during its fabrication, but the rest of the time during operation, there is very less maintenance cost is involved over there. So almost during that period, you can say it is clean source of energy. Okay, so and economic, of course, it is economic because the solar. For example, India is most of the part is comes tropical region. Okay, so we are blessed with this. In Hindu mythology, the sun is also a god. Okay, so God's son is blessed, heavily blessed to us. Okay, in India especially. So, and inexhaustible. So, as compared to our life and many generation, it is inexhaustible. However, certain life of the sun is there, that we know. Okay, so with that respect, with the time frame, okay, we can say it is inexhaustible. Of course, convenient. There is not a rocket science to convert the solar radiations into the heat energies, to convert into the solar radiation into the electrical energy. Okay, so the conversion technology is very economic now these days and very convenient, and that technology is available everywhere. As far as concerned with this solar thermal technology, this is totally the greenhouse effect. Okay, so now this classification you can do classification solar thermal system, the concentrating and non-concentrating. The concentrating and non-concentrating, that is because of concentration ratio. Okay, so concentration ratio is basically so this is very important thing, and in case of the flat plate collector, the concentration ratio is 1. What is that? Why it is this one? Because the absorbing surface, receiving and absorbing surface both are having same area. Means the flat plate collector is there, and the flat plate, the standard flat plate collector having the dimension of the 1 meter width and 2 meter length. Okay, so in that the 1/2. Okay, so in that 1/2, the radiations are coming all on that surface itself, and receiving and solar radiation receiving and absorbing surface area both are the same. Okay, in case of evacuated tube collector, receiver area is and different to the absorber area. Okay, so because the absorbing surface area is in denominator. Okay, so that's absorbing surface area is reduced as compared to aperture area or the receiving area. Okay, then its concentration ratio is increases. So those kind of concentration, those kind of collector, those kind of solar thermal energy conversion systems are known as the concentrating device. Okay, so this is parabolic tuff collector, linear fractional collector, solar parabolic dish, solar tower. I forgot to tell this. Flat plate collector can give us the temperature in the range of easily 80 up to the 80 degrees centigrade. Evaporative tube collector up to 180 to 220. That depends on the condition, environmental condition. Okay, so that also dependent. And in fact, the insulation is very important factor in that. The heat losses. Okay, insulator. Now the parabolic collector. I will show you all the picture. Parabolic collector. This parabolic collector up to 250 degrees centigrade you can easily achieve. Linear fractional collector up to 200 degrees centigrade. Parabolic dish up to 600, 700, 800. It depends on the concentration ratio. Okay, solar tower, helistatic type, because the collectors basically reflectors are there, and all reflectors focusing towards on the tower is there, and the tower at the top absorbing device or the energy storage device is there. Okay, so whatever the energy is received means the reflected solar radiations are falling on the surface, on that area, on the device. Okay, so salt hydrates are generally used because in the salt hydrates generally melt more than the 80 degrees centigrade. Okay, so these are the brief picture of the concentrating non-concentrating devices, which are useful, which are basically convert into the solar radiations into this. Okay. The same picture, the flat plate collector, evacuated linear cylindrical parabolic concentrating device, the PTC, the spherical parabolic dish concentrator. Okay, so now that I have already discussed. The flat plate collector, the temperature is low up to the 80 degrees centigrade. Flat plate collector with the double glazing. Yeah, because glazing means number of covers are there. Okay, and number of covers means if suppose one cover is there, definitely convection and radiation losses are less. Two cover, no, more as compared to two glazing. If suppose we have the three glazing, one glazing, second glazing, and third one glazing. Okay, so like in that way, if we increase the glazing, then definitely its convective and radiative losses are less. But more than 2 glazing are not advisable, and because it is not economic. Okay, and solar bond technology, of course, it is a low temperature device. Okay, low temperature working device, low temperature energy solar energy conversion device, but it is also very useful. But here we need to maintain the salt gradient. Okay, so salt gradient, actually the salt gradient is act as a insulator, thermal insulator. Okay, but in this solar pond also we have also various applications. The solar ponds are being used for the power energy, power development, power generation, with the help of organic Rankine cycle. Okay, sorry, and this ETC, evaporative collector, medium up to 200 or 180 to 200, 200 or 220, that depends on the working condition. CPC, compound parabolic concentrator, up to 200, cylindrical, linear or surface, medium high up to the 280 or 300 maximum, and central receiver, parabolic dish. Oh, okay, sorry, but this parabolic dish is not there. Central receiver very high up to the 800-degree temperature you can easily achieve, and for any industrial application, 800-degree centigrade temperature is more than enough. For the power generation itself, you need a 650 or 700 degrees temperature only. Okay, so this is a typical picture of one experimental setup. This are taken from the Oran et al. Okay, this is the maximum optical thermal efficiency was enhanced by increasing the concentration. Concentration means the concentration ratio. As we increase the concentration ratio, its thermal efficiency is increasing. The maximum enhancement is 47.7%, was observed using 0.1 volume concentration. Okay, so this is a very good study. You please go through, whosoever is working on the parabolic tuff collector. Okay, so with the help of the system, and in fact they prepared one testing, the complete characteristic curves you can develop with the help of this such kind of systems. So what kind of different equipments are required, okay, for characterizing the such this PTC collector? Yeah, okay. So in overall, its thermal efficiency was enhanced by the 2.19%, and outlet temperature did not exceed this one. So main thing, basically, the such kind of system is parabolic tuff collector is there. If you would able to see, this is the solar radiation logger, data logger is there for measuring the solar radiations. Okay, this is a tracking system circuit, or this circuit helps a motor, a stepper motor, or any other. So this electronic device is help to trace the system. Tracing means the system should always to the perpendicular to the beam radiations. Okay, so because sun is moving from east to west, and altitude means latitude angle is also varies from altitude angle is varies from 0 to 90 degree. Okay, in morning it is on the zenith almost. Okay, and sun is moving from east to west, facing towards south position. Okay, in northern hemisphere conditions. Okay, so and of course we need to know the water flow rate. Okay, and the temperature, different temperatures, inlet, outlet, and mid, many temperatures are required. So definitely the data temperature recorder and data logger is required for the temperature recording temperature at different places. Okay, so pump is also of course needed because of this is the forced convection type system. So for the different mass flow rate, you can have the characteristic of this system. Okay, and they have also, this is because this is other work, but I have considered over here to discuss because this is very wonderful work, or in fact for the basic understanding of how the parabolic tuff is characterized. Okay, you can see over there are the two parabolic collectors are there. Okay, this is parabolic reflector, this is curvature, curve like things, and mirror polish is there. It could be the stainless steel or small mirrors also there. Okay, however, this fine grade polish of stainless steel is preferred. Okay, and this is absorber tube basically. This is absorber tube, and concentrating with the two. It is concentrating with the two layer of the two cylinder, two glass cylinders. Okay, so again further, we want to suppress the heat losses or the convection or radiative losses from certain absorber plate to environment. Okay, so that's why the two concentrating cylinders are there. Okay, so ideally there should be vacuum. If suppose vacuum is not there, then it is also fine, because the maintaining vacuum between these concentrating tubes are very difficult, right? So so this is a very practical approach, and definitely if suppose if in your such kind of the systems, if you could able to install in your university or institute, really it will be very quite helpful for understand the UG level student, PG level student, how the system works and the characterization. So such kind of system I would like to recommend to your institute. Means many students are there, many scholars are there, and I hope many teachers also some teachers could be there who are teaching solar energy or solar thermal energy conversion process. Okay, so and beauty of this system is they have also provide the this heat energy storage system also over there. So during option sana, they can this system could be work, right? So this is one thing, one story. And now this is another application from Dr. Karim. He's from Australia, did PhD from the NU Singapore under the guidance of Professor Havlatar. So actually this he also demonstrate in his lab the system. Okay, so now just to see over here, this is basically artificial. Okay. So this let me read, and then I will so different here is cursor. Yeah, so the hot oil pump, the heat transfer fluid is over here, this oil, the hot oil storage tank is there, parabolic dish with the aperture area of the 2.88 meter. Okay, aperture diameter is 2.88 meter, and curvature radius is 3. Okay, now the receiver average this is this now just see over here, solar concentrating this is the area, then this one is receiver, and this one is here. Okay, so ultimately what is happening over there, this is the air is blown with the help of this blower. Okay, and the heat exchanger 1, heat exchanger 2. Okay, air heating box are there. These are basically air heating box, and right. So such kind of the demonstration means experimental setup you can easily establish in your lab. Okay, to demonstrate again the research level student or UG level student also, it would be very helpful. Okay, so now the influence of the some effective parameter, the thermal performance of the system is investigated. The oil mass flow rate and receiver aperture diameter have a significant effect, because these are means very influencing parameter in case of the thermal efficiency. Okay, so the initial mass of the oil in the storage tank was negligible effect. The thermal performance of the system was investigated by Karimi during the various day. They have considered the various cloudy condition, means the even cloudy weather they have also tested the same system, and at the optimum value of the mentioned parameter, the daily average thermal efficiency could be up to the 60%. And now just you see the efficiency of the power plant, any coal-based power plant, it's not more than the 35 or 36 or 38. Okay, and even the gas turbine-based plant also is not more than the 65, or maximum at the most not more than 70. Okay, but here we are not in during the its operation time. There is no expenditure on the energy, basically. Only whatever the freely available energy is there, that we are converting. Okay, so such kind of systems are for the space heating. Okay, they have demonstrated in the laboratory level, but the same system can be implemented. A very, very simple system is there. Okay, with the help of this, you can do n number of things. The energy efficiency you can do. Okay, and you can do overall exergy analysis. Okay, second law of thermodynamics, you can implement it. Find out how much the useful energy is there. Okay, so and many other factors be based on mass flow rate of the oil. You can optimize all the operating parameter, especially operating parameter. First, definitely during design, you need to have some good software knowledge. Red screen software is there, and ANSYS also you can do. Okay, so now just see the system is having the more than around the 60% thermal efficiency. The performance of the present system is compared with the other solar air heater, right? So this is very recently they have done this exercise. However, see, many people might be thinking like, what is that in system? Nothing is there, but there is a lot of things are there, because freely available energy is being converted into useful things. Okay, so in European country or the country where the more than what is called more than 9 months are winter period. Okay, so these such kind of applications are very useful, and there are huge expenditure of conventional energy for the running the boilers, and all boilers are running with the help of the coal only. Now some of them are using the biomass. Okay, so this is one innovation. Now just to see different applications are there. Okay, we can implement, like the drinking water, the water desalination of purifications, solar desalination. This is low temperature application. Everything is happening at the ambient conditions, and in fact now researcher or okay, and in fact customer, they also want the system should work on the ambient condition. Okay, so we can integrate this the other technology also. One of them is ultrasonic technology. I don't want to discuss it more over here. Okay, because time is very short. I have coordinators have given me the half an hour. Okay, so I have to maintain on the time also. So now this see the drinking water, the solar desalination, and the various desalination techniques are there. Some of them I will discuss with you. Some basic things I will discuss with you. Okay, so in the food, the cooking, crop drying, milk pasteurization, these are all crop drying is maximum allowable temperature of any crop is not more than 72 degrees centigrade. Otherwise, if the temperature is more than 72 degrees centigrade, it will degrade. Okay, so quality of the dried parameter, dried crop will degrade. Okay, crop drying, cooking of course some higher side temperature is required over there, and many of you have already visited to Brahmakumari in Mount Abu. This is a very good example, and the Shirni ke Sai Baba over there, the daily people are having meals with the help of the solar energy only. That meal is cooking with the help of solar energy. Okay, and both of these systems are designed by the Mr. Deepak Gadia. He is a Gujarati pen, and who have worked with the Schaeffler. Schaeffler is a scientist from the Germany. So Schaeffler disk is there. The SF14 is very, very common now these days. Okay, for the comfort, the space heating, water heating, space heating, as we know, for the thermal comfort, for water heating, active space heating, space cooling and refrigeration, passive space cooling and lighting application. Okay, so these are the various household uses. Okay, right now the food and industry uses, just see the dairy, the pasteurization. Look at this temperature. That in the dairy, the pasteurization temperature is 60 to 80 degree. Sterilization is 100 to 20 degree. Drying is 120 to 80 degree. Means 80 degree, 180 degree is basically the completely wet temperature, and you need to complete dry. Okay, in that case, but the most desirable temperature where the drying is being conducted of any vegetable or fruit dried food, dried vegetables are there. In that case, it is not more than the 72 or 80 to 85 degrees Celsius. So concentrators, they are working on the 80 degree up to 80, boiler feed water up to 90 degree. Tin food sterilization, the total range is the 100 to 120. The pasteurization is say in the cooking, bleaching. Okay, bleaching in the tin food up to 90 degree. Flour and the byproduct sterilization, tea preheating 90 degree. Drying is again the 122 in the tea, especially tea processing plant, 110 to 120 degree. Okay, so this much of temperature you can easily achieve with the help of solar thermal energy conversion systems. Okay, these are the different industry. The textile and paper industry, just you see the bleaching, drying up to the 90 degree, drying and degreasing up to 130, dyeing 90, fixing, pressing. Okay, so not more than the 200. You will find that these industry, you will not find the operating temperature of any process is not more than 200 degrees centigrade. Okay, so pulp, paper, pulp cooking, drying, boiler feed water, bleaching is maximum temperature bleaching up to the 150 degrees centigrade, and that temperature you can easily achieve with the help of evaporative type collector. Okay, ETC. You can easily achieve with the help of the ETC. Now the agriculture, the food grains, drying food grains or say vegetable foods, they are not more than 100 degrees centigrade. Okay, or boiling, fruits drying 80 up to 80 degree, pulp processing up to 100 degree, and sericulture, cocoon processing is not more than 100 degrees centigrade. So that much of temperature. So you have gone through all the temperature range of different operation in the different industry, and none of the process is required more than 200 degrees centigrade. Okay, so that is my purpose is show these data is to generate some interest in you. Okay, so please don't think like solar energy is not much useful. Okay, but just look at over there on the industrial operations at what temperature they are working. Okay, so based on that you can define which kind of solar thermal system is most suitable. Okay, so now this solar drying system is very important for me because my area is the solar drying systems only. Means I have done few work on that solar drying system, and as the Dr. Geetam has mentioned one patent, that patent is from the solar drying system itself. Okay, so now this simple hybrid kind of the direct hybrid drying systems we have developed over there for the household, basically for the drying chili, potato chips, capsicum, tomato flex, onion flex. Okay, and these like onion, many or maybe you in your mind you might be thinking like why they are drying the tomato. Okay, because tomato you know the cost of the tomato is goes up to 120 180 rupees per kg. Okay, so during that system the dried powder is very much useful. Just you mix some water and make it paste and use it as a fresh tomato. Okay, some flavor might be changed definitely, but it will work. Okay, so during the harvesting time you can do that. So excess you might have seen in news this many of tons the farmers are not willing to sell into the mandi because the transportation cost is extra burden to them. So what they are doing, whatever in their field they will keep like this, so they are rotten and other thing. Okay, so sometimes so excess amount of excess this cultivation. Okay, that during that time you can have that process drying. Okay, so this Prakash and Kumar, my name is Anil Kumar, and Prakash is Om Prakash. He's my scholar. In 2014, built and tested the modified greenhouse dryer at Maulana Azad National Institute, Bhopal. I was there in the Maulana Azad NIT Bhopal from 2010 to 2018. So that I think someone is dropping some message. Okay. Geetam, whenever you want, you can stop me, okay? Oh. What? Okay. Yeah. So this.
Thank you, sir.
Yeah. I was saying, whenever you want, you can stop me, okay? I will continue otherwise.
Yeah.
Okay.
Sir,
So,
with 2-3 minutes, we can.
Okay.
We have another session actually also.
Okay, fine. So I just want to say over here, this is the one of the dryer. Very simple and modified means we have done some modification in the conventional drying system. Okay, these are some modification, like north wall is opaque because sun is moving from the east to west, and if suppose it is not opaque, the most of the radiations is passing through this north wall. Okay, so we have to stop these losses, these solar radiation losses, and at the same time we have spreaded this black polythene sheet with having some holes. Okay, so such kind of modification we have done, and it works. Okay. Now the latest my student and recently we have designed. अभी बस 5-7 मिनट बाद है क्या है? Okay, अच्छा मैं आ रहा हूँ. So recently my student Anand Kushwa, actually he has done a lot of work with many publications with the same system, but same system means lot of exercise he has done and many good research paper he has published. Okay, based on this system. So this is the latest innovation on in my lab. After that I will stop over here. So this is a greenhouse drying system. The two trays are there. DC fans we are using for controlling its humidity or airflow rate, and because in the drying the temperature, airflow rate, and the relative humidity, these are very important, very sensitive parameter for the drying. For the faster drying rate we can maintain over here, and PV modules are basically used for whatever the energy generated with these PV panels are being used for the DC fan itself, right? And the various thermocouple sensors we have plugged many positions to record this temperature, and this is the evaporative type collectors. 2 evaporative collectors are being used. Okay, and in fact this is the fluid, the water or fluid storage tank over there, and this system works very nicely. Okay, rotameter is for the flow meter. At the different flow meter, at the different mass flow rate of water, the system efficiency, system performance was observed. Okay, so recently we got one sustainable energy and technological assessment, one recent publication, and many more we have already published based on this system. Right. So this is a hybrid type energy solar drying system, and such kind of systems are very useful for the domestic lady and a small scale industry. For the cottage industry, we can implement this system, and based on that some patent is also filed. It is under consideration. Okay, so with that word I just want to stop over here with this. If you have any query, then you can ask over here from me. Otherwise, you may. My contacts are over there.
Thank you so much, sir.
Yeah.
Thank you so much, sir, for insightful session on solar thermal system. Any participant would like to ask some questions regarding the session? Anyone participants would like to ask any query regarding this solar thermal session?
Sir, one question I want to ask. Sir, as we know that most of the power we are producing by using thermal power plant, and the efficiency is always the issue with thermal power plant. So is we have any mechanism to improve the efficiency through solar thermal system?
Yeah, like the preheating or pre-moisture removal you can do with the help of the solar thermal systems. You can implement the solar energy in the conventional type system itself, conventional power generation system itself, right? So for the moisture removal of the coal, that you can do, okay?
Right.
And in fact, for the preheating of the water, that for that place you can implement the solar thermal systems. So
Right.
definitely with this, by this way, I believe up to the 5% efficiency you can improve.
And we can improve the efficiency in turbines also.
Yeah, no, that is a different section. You asked me how the solar thermal energy concept can be implemented in the conventional type of system for enhancement of its performance, right? It was the question, right? So with that respect, I answered.
Thank you, sir.
In turbine side, that is in turbine the thermal energy conversion in the turbine efficiency, that is a different thing. Okay.
Thank you, sir.
Yeah.
Thank you, sir. Thank you so much, sir, for a wonderful session with you.
Okay. Thank you, organizers, for calling me over here for this invitation.
Sir, thank you.
Yeah. Shall I quit now? Thank you, madam. Namaskar.
Thank you.
Yes, sir.
Thank
Yes,
you.
sir.
Thank you, sir.
Thank you, sir.
Multiple blade type. So this you can see the multiple blade types. These were used in earlier times for grinding the grains. So these are conventional windmills, like we were having conventional water mills also for grinding the grains. So this is another way you can see this conventional mill used for the grinding. So if we see the wind energy conversion system, basically in the wind energy conversion system, whether it's a high speed or low speed, it has to have some kind of electrical generator, and this electrical generator generates the power taken from the wind power mechanical energy and converts it to electrical energy. And this is one of the conversion block diagram where we are using a squirrel cage induction generator, or we call it SEIG, also self induction generator. If we are having that kind of system, then there is a system and it is converted, because maybe initially this speed is very low, the power range is very low, but it is converted through this converter inverter combination, and it is made to match the frequency and the voltage of the grid, and then it is fed. Now in this process, sometimes we draw reactive power for energization of this squirrel cage induction generator if we are using a squirrel cage, And if we are using a PM, permanent magnet generators, then there is no need of this and it can be connected directly. Or there can be any other machine. So there are operations on the type of machine or research on the type of machine to be used, and then associated control schemes and the converters. So if we see R&D challenges in the wind energy, it's a variable power generation. We know that the power cannot be constant because wind energy or wind flow cannot be constant. Then selection of generator, matching the power demand and supply, system behavior under sudden change. Here also the sudden change may happen. A sudden wind gust may come, or wind may be zero at that point. So how to manage that? Because the load is not going to wait for your wind to blow. And control of power flow, then here also maximum power tracking is required. So these are the areas in which anybody can work on. And similarly, there are many kinds of renewable energy systems like solar photovoltaic, wind turbine we have already discussed. Then it can be having micro hydropower, geothermal, thermoelectric, tidal or wave energy generation, biomass energy generator, and diesel generator also, because suppose you have all these and at any moment all of them are not available, then your load will not wait for that. So you have to have some kind of backup, and the at many places are used as a backup power source or backup energy source. And if you have all these combinations, we can say that it's a kind of microgrid which uses the DG as a backup energy source. And we can have power converters, battery energy storage for critical loads, controllers and actuators, and then the protection system. So this is a kind of typical microgrid system. At present, there are many people who are doing the research in this microgrid systems, in which you can have, here you can see this is a wind turbine, then you have a solar, this is a kind of boost converter used for maximum power tracking. Then the batteries are there. This is also for maximum power tracking from the solar photovoltaic. And then we have a inverter system. DG is connected on the load side. There are linear and non-linear loads. So this kind of combination, anybody can work on such kind of microgrids depending on the availability in that particular area. These are few glimpses of microgrid configuration which can be seen. It is from one of our group's paper. Solar photovoltaic and wind turbine based microgrid systems with different generators. You can see synchronous generator is connected, squirrel cage induction generator, permanent magnet synchronous generator, doubly fed induction generator, permanent magnet brushless DC generator, and synchronous reluctance generator. So any of the generator can be used. You can work on any of the generator, but associated control is very much required in these cases. Then it can have the diesel generator also, solar photovoltaic and diesel generator. Diesel generator can also have different types of machines. Then you can have micro hydropower. You can have the combination of three, solar, wind, and micro hydro. Or you can have solar, DG, micro hydro. These are the configurations. So you can have many configurations. And here you can see that these configurations are connected on the DC side. So basically what we are doing, whatever power is generated is converted to a common DC voltage, and then this DC voltage is converted to the desired AC side for the synchronization. So this enables the system to work in on one side, and only one generator, one inverter is sufficient enough. Otherwise, what you need, you have to synchronize each and every generator separately, and that creates sometimes problems. So to reduce the complexity, we have proposed this kind of configuration. Anybody can think of any other configuration with the reduced complexity, and that can also work. So the research can go in that direction also, that how you are reducing the complexity of the system, and at the same time the cost and availability of your energy sources should be managed properly. You can have combination of all of them. Suppose we have a place where we have some of the water flowing for say 2-3 months, and then wind blow is there for some of the period, solar is available. Like in rainy season, solar is not available, but this micro hydro can work, because then water will be there or wind will be there. So you can have such kind of combinations depending on the requirement of that particular area, and then you can decide a microgrid system, but it must be in you can say connection with the requirement of that particular area. So if we have these things, we have to have a coordinated control. So we call it coordinated control strategy, and in renewable energy system based systems, additional power converters and energy storage are required for the power balance in the system during the load and weather perturbation. That means if load and weather is changing again and again, and even then the uncertainty of power may require DG for the backup. Therefore, a coordinated control strategy is required, and what it actually does, it goes for the synchronization. If you are having separate sources connected separately, then synchronization is an issue. Then power quality improvement, that means the power should be of good quality. It should be sinusoidal. Its THD should not be more than the stipulated standards. Then frequency should not go beyond the range. Many things are there. Then efficient operation at light loads. Suppose the load is not there and you are generating, then there may be frequency shifts. So that has to be managed. Then optimum operation of all the generation sources. If power is required less, then the cheapest source should be given the preference. That kind of coordinated control strategy is required. Then the power balance in the system in the presence of perturbation. So many things are being explored and can be explored. You can add many things to this also if anybody is interested for that. So I finally conclude that if we are talking about the renewable energy systems and the you can say generation side energy management,